Physical Science, Module 15B. We'll be talking about wavelengths and the frequency of light, or light frequencies, I should say. Our vocabulary words: visible spectrum, the electromagnetic spectrum, ultraviolet light, X-rays, gamma rays, infrared light. As just a review, we need to remember that frequency of sound determines the pitch of the sound heard. Just like sound pitch is determined by frequency, the frequency of visible light determines color. Experiment 15.1, that used the mirror reflecting sunlight onto a white piece of paper, results in a rainbow being produced. The rainbow is produced by light traveling through different mediums. The light tends to bend differently through those different mediums or different substances. And when sunlight hit the water in the experiment, the light bent. Some wavelengths bent farther than others. The mirror reflected the light, and the light traveled out of the water, causing the light to bend again. The light bent enough to separate one wavelength from another wavelength. In this picture, you can see the separation of the wavelengths by the separation of the colors. The result was a separated wavelength shining on the white paper, creating this rainbow. So here we have a picture of a rainbow, and you can see the visible light spectrum right here, with red on one side and violet on the other side. The visible light spectrum is actually white light that's made of many colors. The longest wavelengths are made of various shades of red, so these are the longer wavelengths. The shortest wavelengths are made of various shades of violet. And in between them are orange, yellow, green, blue, and indigo. Now, one picture I showed you showed the red over on the left side, and this one shows the red on the right side. Depending on which scale you look at will be what side they're on, and depending on which rainbow you look at will also be what side they're on. It will depend on the reflection. It's important to remember the relative size of the wavelengths. Red light always has the longest wavelength. Orange light will be slightly shorter than red, and so forth. It's important to remember the order of the wavelengths and their size. So one of the ways the text suggests is an acronym that can be used to remember the order. Roy G. Biv can help you to remember that red is the longest and violet the shortest. Red, orange, yellow, green, blue, indigo, and violet. So if you put red on the left side, then violet will be on the right side. Red will be longer, violet will be shorter. The light we see with our eyes is the visible spectrum of light. A representation of the electromagnetic spectrum below shows a more complete picture of the different types of waves in creation. So we have infrared light right here in the middle, and to the right you see radio waves, television waves, and microwaves, television waves, and radio waves. They have very long wavelengths, as you can see from the image. Over on the left side, you see shorter wavelengths, and we go from visible light to ultraviolet, which is a little shorter, X-rays, which are shorter even more, and gamma rays, which are very short in between the wavelengths. Electromagnetic waves with wavelengths shorter than visible light are called ultraviolet light, X-rays, and gamma rays. Ultraviolet light has enough energy to kill living tissue. X-rays have even more energy than do ultraviolet light rays, and so can be more dangerous. When a doctor takes an X-ray of a broken bone, some cells in the body actually die. The cells also run the risk of being mutated. Consequently, it's important to limit X-ray exposure. This allows the body time to replace the lost cells and eliminate any mutated cells. It's also important for the person giving the X-ray to be shielded from those rays. That's why if you go for an X-ray, the person will get behind a big plastic shield with a window to protect themselves. Electromagnetic waves with wavelengths just longer than visible light are called infrared light. The light from a hot object giving off heat is infrared light. Think of a space heater or a fire at camp. Wavelengths slightly longer than infrared light are called microwaves. When you heat up food, you're exposing it to long wavelength electromagnetic waves. So the next time someone asks you, what are you doing? You say, oh, I'm exposing my food to long wavelength electromagnetic waves. Microwave ovens work because the particular wavelengths used in them are absorbed by water molecules in food. The waves are absorbed and the water molecules begin to spin due to the energy absorbed. When the molecules start spinning, friction that generates heat is created. Microwaves cause the water molecules throughout the food to spin and heat right away. This is different than ovens. Ovens, on the other hand, cook from the outside in, which is a longer process. Microwaves cook basically all throughout, and this speeds up the process. And that's it for this module. Almost. One more slide. Electromagnetic waves that are longer than microwaves are used to transmit radio and television signals. So when you're looking for a particular channel, you're actually looking for a particular frequency. Television signals have shorter wavelengths than radio, and FM signals have shorter wavelengths than AM signals. That's why on your in your car, when you're dialing for radio stations, the AM stations will be louder and stronger than those of the FM stations. So, this completes this section of Module 15. We'll be coming back to 15C. And if you have any questions, be sure to ask me. One of the things I wanted to also point out was about infrared rays. So let's go back to that slide. You've probably seen pictures like this, or actually movies where they'll show something spooky with an infrared ray. Well, the way that they could do that is they have special lights that can pick up the light from the infrared spectrum. And also something that picks up infrared, which is very important, are night vision goggles. They actually have special lenses that help them pick up infrared, and that's why they can see objects that are giving off heat in the dark. So hopefully this was informative, and we'll talk again soon.